Question number one way to assess stability of measures of computing Pearson is correlation coefficient, coefficient criterion, coefficient of determination, none of them. In order to make research reliable, it requires that there is deliberate attempt to either conceal or highlight something repeatedly and accurately. Accuracy are provided for quality measurement procedures. Quantitative and qualitative methods are to be used. The solution, the research problem is known in advance. So before I answer these questions, I'll take you to some background information of what we had learned. So question number one looks at a topic called measurement and reliability. So we use what we call the Pearson's correlation coefficient to measure the strength of the relationship. So we have what we call the Pearson's correlation coefficient, and also we have what we call stability of measures. So for us to understand this, we will briefly elaborate for those of you who missed that class, just to get in tune. So under SPSS, we have a functionality which we call coefficient of correlation. So when you're measuring stability or stability measurement, we are referring to the degree to which the test instrument is consistently yielding the same results under different points or conditions. So it is very important to have a retest reliability in a number of fields like psychology, education, and medicine, and other faculties. So a stable measure in research implies that the variations in the scores would be due to actual changes in the construct that is being measured. So we have what we call the Pearson's coefficient correlation R from our QM. So R stands for a linear relationship between two variables. So now R has to be between a range of -1 to +1. So when you're interpreting your results and you get an answer which is negative, it means that there's a negative relationship. If it is 0, it means there is no relationship. If it is 1, there's a perfect positive relationship. So now why do we use a Pearson's R correlation to assess stability? So in a retest reliability, it is usually administered to the same group at 2 points in time. So the Pearson's correlation between time 1 and between time 2 intervals will determine how stable the measurement is. So as a researcher, for instance, you want to administer an IQ test for UNILA students on Monday. Again, 2 weeks later, you'd want to administer that on a Monday. So if you get your R, which is 0.85, who remembers, what does it mean? 0.85 means what? 85% of your dependent variable is explained by the independent variable. So that's what it means. So 0.85 means there's a strong relationship. There's a strong relationship. So anything above, let's say, anything above 50% is a strong relationship. So if you have 0.80, it is very high relationship. Between 60 and 79, it's moderate. Less than 60, it is a low stability. So these are the concepts you need to understand. Because I found situations where people are doing their defense and they're not understanding these things from our QM. Okay? So we need to understand the interpretation of these figures. So R is, we also have a figure called R squared. R squared is coefficient of determination, right? R squared is a coefficient of what? Determination. it is used to measure the strength of the relationship. So it measures the percentage of variance of one that is explained by another. So if your R is 0.8, R squared is 0.64. So it means 64% of the variation is explained. So it's important to understand R in the context of research because you want to ascertain causality. So sometimes you want to undertake what we call a advertisement launch. So when you have an advertisement launch, you may want to see how much your advertising budget affects sales, for instance. So in that case, you need to ascertain causality. Okay, you need to ascertain causality. So in that context, you say how much of the sales were attributed by the advertisement budget. So if you got something like 0.3, obviously the management team would not accept to give you the advertising budget. So that's what we are talking about. All right. So R squared stands for the coefficient of what? The termination. So when you have 0, it means there's no relationship at all. So these are the things that we are talking about. Any questions so far? So besides us trying to understand what R is, I want you to understand in that context. So now let's go to our question. One way to assess stability of measures is by computing a Pearson what? Pearson correlation coefficient. Okay. Then question number 2. In order to make research reliable, it requires that. So how do we make research reliable? So now we are talking about issues of reliability. So again, before I go to answering that question, we have discussed issues of reliability in research. What comes to your mind when you're looking at reliability in research? What comes to your mind when you're discussing reliability in research? So reliability looks at what? The consistency or dependability of the research instrument in research. So when a study is deemed to be reliable, repeating it under the same conditions should actually yield the same results. So we talked about the different types of reliability. We talked about the test, retest reliability, inter-rater reliability, internal consistency reliability, and also parallel forms reliability. All right. So we discussed all these concepts. Now, what did we say about these reliability tests in their context? So we say that when you're looking at reliability, it becomes a cornerstone for quantitative research. So some of your supervisors will ask, what tests did you conduct to ensure that your results are reliable? We can rely on them. So the test retest reliability is used to measure stability of test over time. So this implies that if you're going to use the same instrument, it is administered to the same participants at 2 different points. If there's a high correlation of, say, 80% between the 2 scores, it means that the stability is high. So readministering that questionnaire after two weeks will imply that test will be the same. We also talked about inter-rater reliability. It says here, we are often looking at who? The rater, the observer. So it assesses the agreement between 2 or more independent observers who we call raters. It is usually used in qualitative research, in clinical diagnosis, in behavioral observations. So a common statistic that is used when we're dealing with inter-rater reliability is what is called the Cohen's-Cooper or intra-class correlation coefficient, ICC. So as we took you through SPSS, there's some of these Cronbach alpha issues that we're looking at in the other class. So inter-rater reliability looks at how the results from two raters are consistent. Are we together? Then we also looked at the third reliability test. The third reliability test, which was the internal consistency, which uses the Cronbach alpha. So what does the internal consistency reliability test talk about? So it checks if all the questions in the test measure the same thing. For instance, if you're doing a happiness test, you should ask questions about happiness. All right. So that is what internal consistency looks at, in short, in simple words. We also have what we call the parallel forms reliability test. Okay. It assumes that when you use two different versions, they will give you the same what? Test. In short, if both will give you the same result, they're reliable. So the parallel form, you use two different versions, but are giving you the same test results. Sometimes if you want to uh, simplify one area, you could use this rapid test or you can use the blood, but if the results are going to find the same parasites, then they are certain that there's malaria in there. So now, what makes research reliable? The same results every time. The test should give you the same results if repeated. The same way of doing things. So you use the same steps for everyone. There should be clear meanings. You need to define what you're testing clearly. The tools must also be good, like questionnaires. There should be no bias, meaning there should be no personal opinions. So what are the wrong ideas that we have when you're dealing with reliability? So reliability is not about hiding or showing answers. Reliability means you need to be consistent. You don't need to be secretive. Okay? It's not only about math or numbers. Even interviews or observations can be what? Reliable. So it's not about guessing the right or wrong answer. So we talked about examples of simple tests like the test retest, a math test that is given to students this week, again after 2 weeks. So if most of the students get similar scores, then the test is reliable. The inter-rater reliability test, if you have two teachers, okay? So two teachers will watch a student's behavior and rate it. So if both teachers will give the same ratings, then it means that these raters are good. So reliability is very important because it helps produce trust with the results so you can believe the findings. That's why when you do the research, they'll ask you to see the Cronbach alpha. In fact, there are people like Dr. Sachin Sambwe who will ask you to produce those results so that he runs them himself. So sometimes the people who cook those results, you're able to tell that these are not consistent. Okay. It also helps in validity. So when a test that is reliable, the test must be reliable before can be valid. Right. So I'm trying to expand on each point so that as we get to answer these questions, you know the basis from which we are coming from. Okay. So we go again to question number 2. What was question number 2 asking? Question number 2, this is our test 2 coverage. In order to make the research reliable, it requires that, what is our answer? It requires that B, repeatability and accuracy are provided for the quality of measurement procedures used. So reliability here, we talked about focuses on what? Repeatability and accuracy of the methods and instruments used in the research process. Are we together? Okay, so let's go to our next question. Question number 3. Question number 3. Okay. So in question number 3, when a test developer gives the same test to the same group and the test takers of the two different occasions, he or she can measure what? I think I explained that.
Test reliability.
Pardon?
Measures the test retest reliability.
Yes, it's a test retest reliability. Okay, we're just from talking about the test. So when the developer gives the same test to a group and takes it over different occasions, what is being measured? It's a test retest reliability. So we said test retest reliability will assess what? Stability of the test over time. So the test is administered to the same people at two separate occasions, then the scores will be correlated. So a high correlation will indicate that there's what? There's good stability or temporal reliability. So this form of reliability is very important in what settings? In academic settings, psychological, or skill assessments. So why is A wrong? Why are the other answers wrong? Validity, because validity only measures how well the measures are supposed to be, not consistency over time. Internal consistency is wrong because it checks what? Consistency of items within a test. The split half reliability test is wrong because it does what? It involves you split testing two halves and seeing if both of them yield the same um, results. Now, just in depth, just explaining these concepts. So before we go, okay, our approach is just not only knowing which answers are correct, we just want to understand the concept behind each of these concepts. So when you're talking about validity, validity basically looks at whether the test we're doing is doing a good job, all right? Validity. What does validity do? Let's go to our notes. I sent you those notes some time back. For those who are new, um, we talked about validity as being what? Telling us whether the test is doing its job, what it's meant to be. Yeah? Are we together? Anyone behind? Or are there any questions so far? All right. So when we talk about validity, like I said, we're looking at what? Knowing whether the test is doing what it's meant to do. Are we measuring the right thing? So imagine if you want to measure how a smartphone uh, is intelligent like an iPhone, but your test has questions about how well they remember. So meaning it's not a valid test of intelligence. Okay, it's actually testing memory. So there are several types of validity tests. Who remembers the validity tests we looked at? Several types of validity tests. We talked about content what? Validity. What does content validity look at? It asks questions whether the test will cover all the important aspects, the content. For instance, a math test should have a mix of questions of addition, subtraction, algebra, geometry. Okay. So if it's only algebra, then some things are missing. Construct validity. What does it measure? It measures whether the test really um, will match the big idea we're trying to measure, a construct. So, for instance, if the construct that you want to measure is happiness, so the test should ask questions about emotion, satisfaction, well-being. So if it's only asking about money, then it's not a good match. We also looked at what? Criterion validity. Criterion validity will ask questions whether the test match real life success or outcomes. So if, for instance, a test says that someone will be a great salesperson, we should see them actually doing well in sales. If not, the test will be what? Invalid. So you need to remember that a test can be reliable, but it may not be valid. For instance, weighing a scale that shows 5 kgs more than your real weight, uh, is it reliable? Okay, it could be reliable because it may give you the same results. It's showing you that it's giving you you are 30 kgs, but showing you 35 every time you go there. Okay, it's reliable. We have reliable liars who, especially men, keep lying consistently. Actually, women are better, but it's not valid. So meaning it's giving you 35 kgs, but it's not valid. So reliability and validity are two different aspects that are different. Are we together? What following?
Yes, we
Yes.
are.
All right.
Yes.
Then we also talked about issues of um, internal consistency, where we use a Cronbach alpha. What does internal consistency measure? So when we're dealing with internal consistency, we are actually answering questions to do with what? Are all parts working together to measure the same thing? That is what they seek to measure or answer. Okay? Are all these parts measuring the same thing? Internal validity. So when we are looking at internal validity, it's a measure of how well the items on a test or a questionnaire will assess the same construct. If all these items are supposed to be measuring confidence, for instance, they should all be about confidence, not about unrelated topics like food or favorite colors. That is what we mean with consistency. They should all agree with each other. All right? So now, imagine I'm trying to use a simple question. If you are designing a quiz to measure self-confidence, so good questions should be, I feel comfortable about speaking in front of people. I am confident. So in the Likert scale, I'm confident about my decisions. I don't doubt myself when I face challenges. You shouldn't add in your Likert scale, what is your favorite type of food? So that question is an outlier. So how do we check this? We have what we call the Cronbach alpha. So the Cronbach alpha has certain ratings that you need to understand. So we went through SPSS. Those that missed, you can join us over the weekend. We do the measures in. So we looked at Cronbach alpha measures. For instance, 0.9 to 1.0, it shows the highest internal consistency. 0.8 to 0.9, that is good. 0.7 to 0.8, that is acceptable. 0.6 to 0.7, it's questionable. You need to review it. And below 0.6, it means the questions could have been poorly matched. Right? So we're just trying to elaborate on when a test developer gives same test results to different occasions, he or she will measure what? The test retest reliability. Okay. So question number 4, a sample is representative. What is a representative sample? A sample that accurately measures data at a lower cost. None of them a sample that has been collected within a short period. All of them a sample that accurately represents data. What is it called when the data source is gathered and compiled with others? Quantitative, secondary, tertiary, none of them primary data. Okay. Who wants to attempt and explain why their answer is correct?
For number 4, what is a representative sample? This is a sample that accurately represents the data.
Okay. Explain. Yeah. You want to give us some explanation?
Okay. A sample that gives accurately representative, meaning you've gotten the right sample size and right representatives to give you the data that you're looking for. You don't just target anyone. But like, for example, if you want to do a research on how the price of tomatoes are fixing, or maybe the sales made in a particular market, you have to, your sample will come from that same market, and the target sample group will be the traders themselves. So that way you get the accurate and representative data that you're looking for.
Okay, that's good. So in your research, I usually have a problem when you're doing your proposals. So in your proposal, some sample design, I think, has been forgotten by most of you who did QM. When you're putting a sample size of 100, what is your rationale? So in research, it is important that firstly, a representative sample should be a subset of what is closely, okay, mirroring, or what closely mirrors the entire population in terms of characteristics. Some of the characteristics we're looking at are demographics like gender, education, and other key things. Now, why is a sample important? A sample will ensure that there are insights that or inferences that we can draw to generalize a general population. So without these representatives, results can be biased and can lead to incorrect conclusions. So our answer in this context, like she said, is that a sample that accurately represents what? Data. This is the most accurate definition because it reflects what? The essence of what a representative sample is all about. Now, there are some misconceptions that you need to understand about sampling. Let's quickly address misconceptions. Number one, that a sample that accurately represents data must be at a lower cost. Cost is an important consideration, but it doesn't define a representation of a sample, not at all. Then part C was saying a sample that has been collected within a short period of time. So time frame affects relevance, but it doesn't affect representativeness directly. So there are some of the factors that we need to know that will affect representativeness of the sample. What are some of these characteristics, if I may ask? We have issues to do with what? The sampling method that you're using. Okay, the sample size that you're using. The diversity of the population that you have. These ones are the key factors that you should be looking at when we're looking at representation. Okay. So how does the sampling method affect representativeness of your sample? Okay. How does it affect representative of your sample? So you need to understand that when we are using our sample size, we usually use the Yamin's formula or these formulas. You need to insert them. So at proposal level, let me fortify on this, since I've been assisting a number of you in doing your proposals. So as you do your proposals, you have not yet been granted permission to do those particular proposals. So in your chapter 3, there's a part that will be called target population. Unless you know, it's okay using statistical data or secondary data. Maybe the population of people at National Assembly are 10,000. But why are you picking 20 or 100? You need to substantiate using what? A formula. So the sampling method is very important, how you choose your sample. So the method you're going to use in selecting will affect how representative your sample is. We know there are different types of sampling methods that we have. We have simple, random, or random sampling, where everyone in the population has an equal chance of being chosen. So this is the best method that we use when you're dealing with representativeness. We also have convenience sampling, where you pick the easy reach. It is not very representative, but you can ask around your friends or people that are near your workplaces or people you work with just to collect information. It's cheaper. We have judgment or purposive sampling, where you pick people who represent a group very well. They are better than convenience because this is subjective. For instance, you want to pick people who only have experienced COVID or people who have a master's degree, okay? Because they are the people that matter. So the sample size is another aspect how many people you want to include. So we know the larger the sample, the more accurate. I've had questions where people will say, we are 100 at our workplace, how many do I pick? If there are 100, pick all of them. That's for the census. That is even better. The higher the sample size, the more representative your sample is. All right? No need of using the formula. But we have the means formula. N is equal to Z squared, S squared over E squared, level of precision. Remember that in QM. So the bigger, the better. But also you need to understand that bigger doesn't always mean better. If your sample is large, but not from one group, it may not represent the full population. So surveying 1,000 people from Lusaka may not represent Zambia. So you need to use tools like the means formula, okay, to calculate the right sample size, not the online calculator. You need to substantiate. So the other aspect that will affect is the diversity of the population, how different people are in your population. So what this means is the population is very diverse, like people have different ages, different cultures, different languages, education backgrounds. Your sample may include people from each of these groups to be represented. So the more differences the population, the more careful you must be in choosing your sample. So you must use stratified sampling to divide population into subgroups like age, location, to have a fairer sampling. So why is representative important in sampling? Because you will get trustworthy results. Your findings will be more likely to reflect what is really happening. Generalization, you are more likely to apply those results to the whole group of population. Better decisions, governments, businesses, researchers will make smart choices based on accurate data. All right. So we go back to our question here. So what is a representative sample? A sample that accurately represents data. Okay. Question number 5. What is it called when the data source is gathered and compiled with others? Anyone? What is it called when data source is gathered with others?
Secondary.
Secondary data. Okay. So we want to elaborate a bit on secondary data, what
No.
it is. Okay, so we are learning. We're not only looking at one aspect of the answer, we're also looking at learning from what we've learned from each other.
Can you hear me?
Wants to?
Yeah, so for me, I think,
Uh-huh.
can you hear me?
Yes.
Okay, so for me, I think it's secondary. It's where information is already there in like in the population or wherever you want to get the data from. Say, for example, books on internet or information that is readily available. Like you're not getting first-hand information.
Okay. Thank you so much. You're being economical with words. The answer is correct, but what I was asking was you to also elaborate even on the others, okay? Because we want to understand on the what? The sources of data. So that is the actual lesson that we have here. So in research, we know data is the backbone of analysis. And data includes you providing raw materials, which is raw information that may either come from the hypothesis, from behaviors, okay? Generally, we can classify these types of data in 3 or 4, primary, secondary, and tertiary data. So what is secondary data? Like somebody has explained, it is data that is collected by someone else for a different purpose, but can be used in our analysis for our own purpose. So secondary data, in short, refers to information that has already been collected, processed, and published by others, which can be reused in a new study. Now, there's different types of secondary data that we can look at in Zambia. What are some of the types of secondary data that we can talk about and the sources that we may use for our researches? So we can use data from where? From government reports, like the Central Statistics Office, the research journals published by academic papers, books, databases like the World Bank, newspapers, magazines, NGOs. So these are the richest materials we are going to be using. So why do we choose to use secondary data, and why is it important? So secondary data has its own advantages and disadvantages. Can you help me identify the advantages that we have on secondary data and disadvantages? These three. Why would you use secondary data? Okay, quickly in the interest of time. Secondary data is time consuming and money consuming, so you don't need to start from scratch. Somebody has already done the research, the hard work. So it's ideal for students, researchers, and institutions because of the limited time you have and the budget. Secondary data also will cover large samples and long time frames. Government and other international bodies will collect data that may cover years an individual may not easily do. And access. So many secondary data are free online, so you can simply access them or libraries and archives. Also, there's support comparison. So if you're going to use secondary data, you're going to have a good trend analysis. You can compare it over time with countries. The limitations is that they're not specific to your study, so data may not really capture what you intended in your research question. You may need to adjust a bit, tweak things. Sometimes data may be outdated. Some databases are old. And maybe potential for what? For bias. If the original owner was biased on collection, your analysis will be biased in that context, maybe skewed. Also, the lack of context. Sometimes you may not understand how the data was gathered or collected, all right? So something may be missing. Then we also have primary data sources. What are some of the primary data sources that we know? Primary data sources, what are they?
Questionnaires.
Okay, yes, questionnaires. Uh-huh.
Surveys.
Surveys, yes.
Focus groups.
Focus groups, correct. So the primary data may be collected by you for a specific question through interviews, surveys, experiments. They are highly relevant and up to date. They are, of course, time consuming and expensive. Well, we also have tertiary data, which comes from encyclopedias, data summaries, indexes. They are collected or compiled from secondary data. So for now, we end here. We'll continue later on. But this is how I wanted us to revise this so that we understand each of these components, such that if the question is tweaked, we're able to follow through. Thank you so much for your time. You have a good day.